good morning, everyone. Glad to see you're here. My name is Johan Bolin. I head up the product organization in Edgeware. And I'm gonna be entertaining you guys for about 25 minutes with some of the innovations we have been seeing in the CDN space the last year or so. And this has been a very interesting year in the CDN space. We have had plenty of new concepts and so on being launched, not only concepts that make CDNs work better, but also concepts that helps customers to enable new revenues and also protect content. Before going into that, a few words about Edgeware. Edgeware was founded in 2004 with a vision that eventually all video and TV will be streamed over internet in a personalized, on-demand fashion. And the only way to do this without jeopardizing the quality is to have a CDN that is optimized for TV. So we call those CDNs for TV CDNs. Since 2016, we are listed on the Stockholm Nasdaq exchange, and we have the headquarters in Stockholm, Sweden. And that's also where we had the lion's share of our R&D. So far, we have built roughly 150, actually more than 150 CDNs in more than 60 countries. So I think we're getting pretty good at that. So I mentioned that we build TV CDNs, and there are a couple of different kinds of CDNs on the market. The most common CDN is a traditional web CDN, a web cache that is used to deliver images, software upgrades, web pages, etc. And these CDNs works perfectly fine also for video if you have rather limited volumes of video, or if video is not a critical part of your business. Once video is becoming a critical component of your business, it might be a good idea to look into a CDN that is more optimized for video. And that's what we do. And also, maybe the use case where you best see the difference between a video CDN and a general purpose CDN would be if you stream large live events. So you're going to understand more about the differences between different CDNs as we go, because a lot of the stuff we're going to talk about today is applications that you typically run in a TV CDN. So when preparing this speech, I created a list with the more important innovations that we have been working with the last year, pretty much. And that got to become a pretty long list. So one of the topics on that list was this: second generation origin solutions, where the ingest and the egress part of the repackager is decoupled. And the good thing with this is that then you can scale your origin and your repackager elastically in the cloud if you're using that. Meaning that, as an example, if you're onboarding a big library of assets, you can scale up the ingest side. Or if you're streaming to a big live event where you have plenty of traffic, you can scale up the egress side. So you can scale the two independently. Another area is ad insertion and what we call server-side ad insertion. Server-side ad insertion enables you to do personalized dynamic ad insertion, but you do it on the server side. And the advantages with that is that you get a user experience that is very similar to broadcast, meaning that you get very smooth transitions from the content to the ad and from the ad to the content. Another advantage with server-side ad insertion is that most ad blockers will not be able to detect the ad, and hence they can't block the ads if you use server-side. And the new thing here is that for quite a while you've been able to do that on HLS, but since very lately you can do that also on Dash. So I think that's the new thing, that you can do this both in HLS and Dash, meaning that you can reach most of the devices with this kind of technology. Latency. Maybe you have tried to watch a live stream on internet and you have realized that the latency typically is somewhere in the range 20 to 30 seconds. A TV CDN have a number of tools to use to minimize latency, and one of the latest tools that you will find in the toolbox is something called chunked segmentation. And chunked segmentation, together with other tools, means that you can actually get latency in a CDN down to a few seconds, maybe 2 seconds, live streaming across the internet. Then we have a very interesting technology that is called watermarking. And watermarking is a forensic tool to track down and identify pirates. So this doesn't prevent content to leak in the first place, but it provides you with a tool to identify the pirates and take legal actions on it. So this is something that could be very valuable for the entire industry. Last year, another thing that happened was that using multiple CDN became very popular. So many big providers, they today use not only one CDN, but they use multiple CDNs, and use multiple CDNs for various reasons. And if you use multiple CDNs, you should have some kind of intelligence that decides for each and every session which CDN to use for that particular stream. And that you do with a CDN selector. Another functionality that we have invested in that is very useful if you have a service that have a significant amount of live content on it. Let's say that you have live football or live sports, is a functionality to do predictive load balancing. And this is because the challenge with live is not only the big amounts of video volumes, it's also the fact that if you have live events, you typically have a lot of viewers being onboarded to the service within a very short time period. And if this is the case, I mean, it's very complicated to allocate resources for that kind of use case. So if you have big live events, being able to predict how viewers will start using the service is very useful. And to use that in your load balancing then. And then we have another big thing here, and this is maybe you're aware of the edge computing trends within telecom, and this is similar to that. This is moving applications and processes that traditionally sits centrally in a video distribution platform and move that out on the edge. That has a number of advantages. Now, these are just few of the things I had on my list, and we won't be able to cover all of these today. So I have selected 3 areas, these 3, moving the stream processing to the edge, TV watermarking, and CDN selection. That's the ones I'm going to cover today. If you want to know more about any of the other 4 I have on this slide, you're of course more than welcome to visit our booth just down, 30 seconds down this way. And then you can ask myself or my colleagues. And we will explain everything you need to know about the other things. So, let's get started. The first topic is moving the stream processing or parts of the stream processing to the edge. And why would you like to do that? Well, before talking about how that would look like, let's start with looking at the traditional CDN. A traditional CDN, you could call it a passive CDN, looks like this. So you have, let's see if I can get this to work. Sorry, you have a number of applications here. Here, you have a number of applications that sits centrally. These applications are the head-end applications and also the origin applications. So here you do like encoding, you do segmentation, and then you do repackaging. And you repackage into the different formats you need to get your content out on all the devices. So typically this is HLS, it might be Dash, and maybe also smooth streaming. And this is, then you cover both iOS, Android, and also a wide range of smart TVs. So what happens then is that all these 3 formats are being pushed out on the CDN. So pretty much you have one and the same content, but being pushed to the CDN in 3 different versions, just in order to work on the different screens. This means that you, first of all, you push a lot of traffic on the network. And also you are caching 3 copies of this material down in the edge caches, meaning that you consume quite a lot of cache storage. So if you would evolve this to a solution that includes edge repackaging, the box here represents the repackaging piece. So keep an eye on that one. So what we do when we do edge repackaging is that we have moved the entire repackaging piece to the egress interface of the CDN instead. And what have we gained by doing this? Well, a few things. First of all, you only send now the content in 1 copy from the head end all the way out to the edge. And this means that you have saved 2 to 3 times the data in the network, and also 2 to 3 times the egress data from the origin. It also means that you only store the content once in 1 common format. So you have also saved yourself 2 to 3 times cache storage on your CDN. And another thing that you have done is that you have moved a functionality that used to be a potential single point of failure from a central site at the origin to dozens or maybe even 100 different sites on the CDN. And this means that if you, for some reason, have a failure in one of your repackagers, there will be plenty of others that are capable of picking up that job. One thing that have happened almost 2 years ago now, 1.5 years ago now, is that you have a standardized format called CMAF. And this means that you can build this kind of solutions without having to use any proprietary formats. So the good thing with this is you can build your entire pipeline that includes edge repackaging and still use a standardized format for that. So there will be plenty of tools and plenty of other systems and solutions that are compliant with this kind of architecture. So, but now you might think that I run all my stuff from the cloud, so this doesn't really apply to me. This was more network-centric, right? But actually, maybe even the other way around. If you run things from the cloud, maybe you have figured out the business model of the cloud. It's pretty cheap to put stuff up in the cloud. Putting content in the cloud is cheap. Getting it out is quite expensive. And delivering content is all about getting it out. So if you are running your head end and maybe also your first layer CDN in the cloud, complementing that solution with streaming servers or streaming POPs that are capable of doing edge repackaging will offload your cloud with 50 to 67%. And since the majority of the single most expensive piece on your cloud bill will be the egress traffic, if you can save 50 to 67% of that bill, that's a lot of money. And then there's one other thing that I think is extremely interesting with this concept, moving the processing out on the edge. And that is that you can now start doing a lot new cool applications. And one of those applications are watermarking. So watermarking, what's watermarking? I mentioned at the beginning that watermarking is a forensic tool. So it's not something that stops piracy in the first place, but it's something that you can use to identify who was the pirate if there is leaked content on the internet. And you might ask, so how much would that be worth? Well, there's a market research carried out last fall in October, indicating that the expected cost for the industry of pirated content will exceed $60 billion by 2022. That's a lot of money. That's almost 10 times Netflix's entire content budget. So this is a lot of money. And so we ran a market research together with a British company called YouGov, and we interviewed more than 4,000 viewers in the US, in the UK, and in Hong Kong. And we asked the viewers, first we explained to the viewer, to the ones we interviewed, what watermarking is, and then we asked, if these streams were watermarked, how would that impact your usage of pirated content? And the conclusion was that pretty much half of the viewers would likely not use pirated content if knowing that that content was watermarked. So now that, I wouldn't say that that means we have 30 billion to invest in new content and technology instead, but I guess it's quite easy to imagine that if you can identify and actually bring some pirates to trial, and you make a big thing of that out in TV and in press and so on, that will scare off quite a lot of pirates. So I think that there really is a big value in this. So the question is, how does it work? There are a couple of different ways to do watermarking. One watermarking technology is what we call the manifest-based watermarking, or sometimes also called the AB version, or the AB method. In this method, what you do is that you create 2 copies of all content. So when you encode the content, you create 2 copies of it. It might be one that is a standard and one is a slightly darker version of the same content. So there's small differences in the content, but you can't really see it with the eye, but there are small differences in the content. And then you segment this content, right? So you chop it up in small segments, maybe 5 seconds each. And then when starting a stream, you take the user identity of that user. It could be a user identity, it could be a credit card number, it could be an IP address. And then you code that identifier into the stream by combining these 2 different versions, the A and B version of the segment, in a clever way. This means that if you find this content in a pirate source somewhere, you will be able to recreate the identifier of the user who leaked the content. Now, this method have a couple of downsides. One, with the advantage with it, to start with that, is that this works on pretty much all CDNs. Now, the downside with it is that it's pretty slow. It takes typically 20 to 30 minutes to detect the watermark. It also has a somewhat limited integrity. It's quite easy to erase the watermark if you get hold of, if you as a pirate have access to maybe a couple of copies of the same content, you can actually reshuffle the segments and then you have erased the watermark. And then another less good thing with this is that you need to have double copies of all content, right? You need to have double copies of the content, you need to send double copies of the content, you need to cache double copies of the content. So it consumes network and CDN resources. So if you have a TV CDN where you can do edge repackaging, there is another technology you can use that is called bitstream watermarking. And bitstream watermarking works in this way. So at the site of the encoder, maybe even built into the encoder, you have a software that is called a profiler. The profiler will select certain frames in the stream. So now we're talking down to individual frames. In these frames, it will identify which areas of the picture can you do small changes in, changing some pixel values that will be big enough to detect with the tool, but so small that you can't see it with your eye. And these potential changes are being stored in a metadata file. And that metadata file are being sent together with the content to the edge. Then when we set up a stream, so when we get a session being set up, we pick some information from that session identifier. It could be, again, the user ID, it could be a credit card number, it could be an IP address. And we embed this into this video stream using this metadata. So now you have actually integrated the watermark into the frames. And the advantages with this solution is that it's extremely difficult to get rid of this, right? So if you put it into the frames, you would need to first realize which frames we have used and then remove these frames. And doing that means ruining the video. Another advantage with this is that it's very fast. So you do the detection of a watermark typically in less than a minute with this technology, theoretically down to a couple of seconds. And another advantage of this is that it doesn't consume any additional resources from the CDN, as long as you have a CDN that is capable of doing this, of course. And we actually have a demonstration of this in our booth. So if you want to see this live, we have a demonstration that we won the IAB Innovation Award at IBC for this demonstration. We have embedded the algorithms from Content Armor, who is a watermarking company, into our Edgeware packaging concept. So go visit us, and you will see a pretty cool demonstration. That was watermarking. The final topic of today is CDN selection, or being capable of effectively using a multi-CDN strategy. And there are a couple of use cases why you would like to use more than one CDN. One use case has to do with managing unusual high peaks. It also has to do with having, if you will, redundancy, having a second or even a third CDN that you can utilize if you have issues with your primary CDN. And this also is a very good technology, good thing, because this means you can optimize your business case. Building out your own CDN could be a very expensive exercise, especially if you need to dimension it for some rare occasions that maybe happens once or a couple of times per year. So smarter then is to build out your CDN to manage the normal kind of traffic volumes you have in your daily usage, and then you utilize a third-party CDN if you have big events where you require some extra horsepowers. That's one use case. You have another use case, and again, how this will work. So the CDN selector continuously tracks the load on your own CDN and also verifies that it's working as it should. And if it either full, meaning you're running at, let's say, 90%, or you have some issues with lost sessions, then you will automatically start dispatching sessions to the third-party CDN or to the other CDN. Another use case is if you're streaming to multiple territories. So in this use case I have on the map here, let's say you have a streaming service where the lion's share of your audience is here in the US, and you're running a US-based service. But you might also have a few customers in Canada, maybe some customers in Mexico or in other Central American countries. And then you use a CDN service or a third-party CDN to reach those users that are off your main footprint, if you will. This use case just got very relevant in Europe, because in Europe they just launched something called digital single market. And digital single market in Europe means that if you are providing a streaming service in a European country, and you have a European citizen being a customer of that service, that customer are supposed to be able to access that service from wherever he is within the EU. And this means that most providers who have built out their own CDNs, they might not have CDN capacity to the other countries. So that's pretty much it. I'm going to sum up what I've been talking about. I've been talking about these three things: moving stream processing to the edge, both to save you money in sense of traffic and CDN storage, but also to enable new applications, where one of those applications are the watermarking application. And the watermarking application is a forensic tool to identify and find pirates. And then I talked in the end now about multi-CDN strategies and how you can optimize those using a CDN selector that for each and every session selects the most optimal streaming platform. So that's pretty much it. I think I have a couple of minutes for questions if there are any. Yes. Do we have a mic for questions, or? No.
Hi. So you just mentioned you did the repackaging on the edge. So my understanding is for your core things now you use CMAP, common media to do from your original to the edge, and at the edge server. So if because your media format is already fixed, is MP4 fragment MP4.
Yep.
So why you need what your repackaging means? You just generate a different dash manifest or
Yes,
HLS,
correct.
but the content itself almost do not touch, right?
No, you create unique manifests, and then since we also support using also transport stream chunks instead of fragmented MP4, so depending on what kind of media format you use, you can also change the media format. But you are correct that in changing between HLS and Dash is primarily about creating the manifests.
Okay. Okay. So you just also mentioned, so now for the low latency, so do you support the Dash chunk, and what's the low latency? Just like you support chunk transfer mode, and you
Correct. So we have chunk transfer mode and then chunk segmentation. We don't have this available in general available products today. We have been doing tests on it. Yeah, we know how it works, so we know the performance you get out of it.
Okay. So, and the last ones you mentioned for the CDN selections, and also you monitoring just like the your CDN balance or load. Okay. Who is the guys who really going to change the routing, or does the client have such kind of things?
No,
but you are doing at the CDN and the network side,
yes,
right?
we do in the routing on the network side. So this is transparent for the client.
Okay.
So we're using a redirect method. So you redirect the sessions to the CDN based on, policies and also measurements.
Okay, thank you. Okay.
Okay. Any other questions? Otherwise, of course, you're more than welcome to visit us, both to see the watermarking demo, but also if you have questions on anything I've been talking about or anything I did not talk about. All right, thank you.